Hi everyone, and welcome to Mr. Hunter's GCSE physics lessons. Today we're going to be doing some electricity revision. We're going to have a little recap of the electricity topic in GCSE, just so you can amend any of your notes or start fresh notes for electricity if you need to. So let's just jump straight in. So the model I like to use for thinking about electricity is based on a truck. And so I'm going to draw a little truck here, and this is my charge truck. Officially it's a Coulomb truck, and we'll see later that the Coulomb is the unit of charge, electric charge, and the truck really is sort of packets of electrons that are making up some amount of charge, because the electron has a fundamental amount of charge per electron. But for now, and especially for GCSE, we can think of it as a charge truck. Now, in my charge truck, I have some energy. And so I'm going to put some amount of joules in here, the unit of energy. And then we can use this truck to define our important physical quantities. So my voltage, V, is equal to the number of joules I have per Coulomb, which is the unit for charge. Let's put it in square brackets so we indicate that these are units. And what I'm saying is that voltage is the amount of energy in the back of each truck. Okay, so I can just write that out with words. And so my voltage is the amount of energy in the back of my charged trucks. My current, I, is equal to coulombs per second, officially. And so in my model, I'm talking about if my charge truck is a certain amount of coulombs, it's a Coulomb truck, then the number of trucks that go past each second is my current. So I'll put number of trucks passing each second is my current. And so then your resistance, your electrical resistance, is the amount of energy you would need to spend, the amount of energy you would need to spend per unit of current, i.e. per Coulomb per second, in order to get over that barrier. So we can look at a circuit to visualize this. So I'm going to draw my circuit out. I'm going to say that this is 6 volts, just to make our lives easier. Okay, there we are. Here's my circuit. And so my little charge truck is going to get some energy from the battery. And it's going to carry, it has 6 joules per Coulomb truck, per charge truck. So that 6 in the back of the truck is the amount of energy. And it flows around the circuit, round it goes, and it gets to this resistor here. Now, we know how much voltage, or the potential difference across this resistor, is going to be, because we know that the charge trucks come back to the cell or battery empty. They have nothing in it, they come back. And so we know that this resistor will have 6 volts across it. And so this leads us to understanding how we measure the voltage. We always do so in parallel. The voltmeter's in parallel. Why? Because the voltmeter is looking here and going, how much energy in the back of each truck is here compared to how much energy is in the back of each truck there. And it measures that difference between A and B. And so the voltmeter reading will be 6 volts because at point A, the truck had 6 volts of potential difference, or 6 joules for every truck. And afterwards it had nothing, and because the trucks go back empty. And so that's the physical understanding of why we measure voltage in parallel and with a simplified circuit. Now, what I'm going to do is, let's copy this out. You can draw a new one if you like. I'm going to get rid of this resistor, and I'm going to put in 2 resistors now. I'm going to say that these resistors are the same, R and R. And the question is, how much potential difference is going to be across each individual resistor? And well, the charge truck has nowhere else to go, so it gets here with 6 volts in the back. It knows, and don't ask me how it knows. That's a quantum physics problem, and we'll think about that in A-level if you end up doing it. But it knows that there's 2 resistors to come. It knows that they're equal in resistance, and so it decides to split its energy in the back equally. And so the potential difference across the first resistor would be 3 volts, and it would be the same across the second resistor. And that's because in the middle, the little charged truck has 3 volts in the back, or 3 joules per coulomb per charged truck. And so it's given up 3 to give over the first resistor, and then it will give up another 3 to get past the next resistor, and then it will go back empty. Now, that explains resistors in series. So we could label these. We could do simple circuit, series circuit. There's a messed up S. There we are. And let's do parallel circuit now. And let's just fix this up. Here's my resistor in first resistor. Here's my second resistor, and I'm going to give them the same resistance here. Now, as usual, our trucks here, they go back empty. This truck here is going back empty. And so what happens when the trucks get to this location? Well, this is where we learn that the trucks, or the current, splits at the junction in a parallel circuit. So this first truck will come this way, truck number 1. Truck number 2 will go this way. Then truck number 3 will go down. Truck number 4 will go down, and so on and so on. And so when one of the trucks gets here, it has 6 volts in the back, and when one of the trucks is here, it also has 6 volts in the back. And so in a parallel circuit, each ladder, or each ring of in parallel, each loop, if you will, gets the full voltage from the battery. Gets this full 6. That's a bit bigger. Gets this full 6 volts. But if you were to measure the current in each one of these loops, it would be half the current of the circuit. And so that leads us on to why we measure current in series. Because all this is doing is counting trucks per second. And so that if we go all the way back up to what our current was, our current is the number of trucks passing each second. And so that's why we measure them in series. Let's maybe annotate this, measured in series. And this one is measured in parallel. And so with these simple rules of how thinking of the electricity as trucks going around a circuit, either in series or parallel, and thinking of the voltage as the number of joules or the amount of energy in the back of each truck, and the truck splitting at the junction, all of these GCSE electricity questions start to simplify down to these basic rules. Okay, so that concludes the electricity truck model, and hopefully that you have found this useful as a bit of revision. Check out the other videos that I'm going to post on electricity. We're going to look at some other things, more of the equations that we need to use.